Okay, so let's start with another question. The number of independent elastic constants for a linear elastic isotropic and homogeneous material is. So this is theoretical question. We all know that the answer is 2 basically, but before solving this question, actually we should know the terminology. What do you mean by elastic isotropic or homogeneous, and what are basically elastic constants? So first of all, let's try to understand the terms so that we can get this answer quickly. Okay, so first see elastic constants. Now here I request all of you to first of all memorize one small table. See, material and number of independent elastic constants. Okay, so suppose the material is homogeneous and isotropic. So number of elastic independent elastic constants are 2. Okay, suppose it is orthotropic, then it is 9, and anisotropic, then it is 21. Okay, so basically you all should remember this values, 2, 9, 21. So what do you mean by homogeneous and isotropic? Generally in strength of material, whatever numericals we are solving here, the basic assumption itself is the material is homogeneous and isotropic. Homogeneous means the material is uniform, okay, and isotropic means the internal elastic properties in all directions are same, equal. Okay, so isotropic, I am just writing here, isotropic क्या होता है? Same elastic properties or equal elastic properties in all directions. Okay, so that is isotropic. Homogeneous is rather uniform, all the chemical constituents or whatever is uniform, so that is homogeneous. Isotropic means same elastic properties in all the direction of that material. Orthotropic is related, ortho means perpendicular, ortho itself means perpendicular. So at a degree of 90 degree, the properties changes, elastic properties changes, right? So here you can give the example of wood. Wood is an example of orthotropic. Anisotropic means in all the directions. Anisotropic, that is change in elastic properties in different directions. Okay, so these are the some of the main terms like isotropic, homogeneous, orthotropic, anisotropic. Okay, so this we should know. At the same time, now the main question is related to elastic constant. So basically we should understand what do you mean by elastic constant. What is elastic constants? See, basically these are those constants which are constant up to elastic limit. Simple. Constant up to elastic limit. We know stress strain diagram, stress strain curve. So up to the elastic point, whatever is constant, they are known as elastic constants. Okay, but this cannot be termed as definition. It is a very raw form to explain you. But basically elastic constants, I am writing down elastic constants are those factors who determine the deformation produced by a given stress system acting on material. So this is actual definition of elastic constants. Those factors who determine the deformation produced by a given stress system acting on a material. Basically they are constants which are constant up to elastic limit. Okay, so here in strength of material, basically we are having, as we have assumed, see what we have assumed, the first assumption itself in strength of material is homogeneous and isotropic. Okay, see this assumption is only for strength of material or mechanics of solid. This assumption is not applicable in RCC. We know, because RCC itself is not homogeneous. ठीक है, तो स्ट्रेंथ ऑफ मटेरियल के लिए ये वैलिड है कि मटेरियल इज होमोजीनियस एंड आइसोट्रॉपिक. ओके, सो इन दिस केस स्ट्रेंथ ऑफ मटेरियल व्हेन वी आर स्टडिंग विच इलास्टिक कॉन्स्टेंट्स वी आर एनकाउंटरिंग. सो बेसिकली हमने कौन से इलास्टिक कॉन्स्टेंट्स देखे, तो एक तो होता है ई है, जी है, के है और म्यू है, म्यू और 1/m. ठीक है, पॉइजन्स रेशियो. तो ई जो है, E is known as modulus of elasticity कहते हैं. ठीक है, modulus of elasticity, और यंग्स मॉड्यूलस भी कहते हैं. ओके, यंग्स मॉड्यूलस. सो E is basically, it is a ratio of longitudinal stress divided by longitudinal strain. Longitudinal means along the length. Okay, so longitudinal stress divided by longitudinal strain, that is modulus of elasticity. Now this stress can be either tensile or compressive. Okay, टेंसाइल और कॉम्प्रेसिव डिपेंडिंग ऑन द नेचर ऑफ फोर्सेस. ठीक है, द वैल्यू ऑफ ई डज नॉट चेंज. देन अनदर इज जी. व्हाट डू यू मीन बाय जी? जी इज मॉड्यूलस ऑफ रिजिडिटी. That is shear stress upon shear strain. So this is also one ratio of two quantities, but here shear stress means tangential stress. Okay, that is horizontal in the tangent surface. Okay, on the surface of the body, that is tangential. Then another elastic constant is K, which is known as bulk modulus. So that is direct stress divided by volumetric strain. And last is mu, that is Poisson's or 1/m. In some books they have written 1/m. So that is Poisson's ratio. That is lateral strain divided by longitudinal strain. Okay, so it is of course unitless lateral strain divided by longitudinal strain. So this is mu is unitless. Okay, So we are having 4 different elastic constants. Then you will feel that why the answer is 2. Why it is here? I have told you that number of independent elastic constants is 2. Okay, so why it is 2? So basic reason behind that is, see, E, G, K and mu, these are total 4 elastic constant. But if by experiment, if we are able to find out any of the 2 elastic constants, other 2 can be easily we can find out. Okay, so we are having lot of equations, so just I am writing down. It is enough to determine experimentally, only two elastic constants. In order to obtain the other two. Okay, so we can easily find out if we are having 2 elastic constants, other 2 we can easily find out. Now how we can find out? So we are having equations. Okay, E is equal to 3k 1 minus 2 mu, this is one equation. Okay, E is equal to 2g 1 into 1 plus mu, this is another equation. E is equal to 9 kg upon 3k plus g, this is third equation. Formula we can use it. So in terms of other parameters we can easily find out. Mu sometimes 1 by m they are writing, so that is 3k minus 2g upon 6k plus 2g, that is also valid equation. Mu is equal to 1 by m is equal to, we are having one more formula, that is 3k minus e upon 6k. Okay, so we are having lot of at least I think these are total 5 formulas, so that we can find out the different elastic constants. Okay, so basically our question was to find out the number of elastic constants in linear elastic isotropic homogeneous material, that is 2. Okay, but I think that you should know the concept also. Okay, thank you very much.